I'm Shota Yamanaka from Yahoo Japan Research. In this study, we tested the applicability of dual Gaussian distribution model in on-screen start pointing tasks. This work is a kind of replication study of this model. The original model was proposed by B and Tsai in WIST 4 years ago, that is, predicting the success rates of tapping a target based on the target size W. Because endpoint variability follows a Gaussian distribution, the probability of a touch point falling inside the target can be computed based on these equations. In their study, as shown in the video on the left side, the participants move the finger from a position outside the screen every trial. This condition is called off-screen start task. In this condition, the target distance is not well defined. Our question is, can we predict the success rates even for on-screen start conditions? We have both evidence and counter-evidence. Some papers claim that the sigma is affected by the target distance, and other papers claim that the sigma is not affected by the distance. Therefore, we conducted on-screen start touch pointing tasks in 4 experiments. On day 1, we conducted 1D pointing tasks. In experiment 1, a new target appears at a random position, and in experiment 2, the start button and target are displayed with given distance A. And on day 2, we conducted similar pointing tasks with circular targets. On both days, 12 participants joined. This is the result of experiment 1, where the target was 1D bar and appeared at a random position. The left figure shows that the endpoint distribution sigma can be accurately computed by the target size W, with R squared is greater than 0.9. By using this sigma, we can predict the success rates for each target size, as shown in the right figure. The mean absolute error for the differences between observed and predicted success rates was 1.7%, and the worst prediction error was 5 points when the target size was 2 mm. These results are comparable to B and Tsai's off-screen start experiments. Next, in experiment 2, we used 1D targets where the target distance was given. The left figure shows that the sigma was affected by the target distance A slightly, and the R squared dropped to 0.8. The right figure shows that the mean absolute error was 3.3%, and the worst prediction error was 10 points. So the target distance affected the sigma and the prediction accuracy of success rates. Therefore, if we take the target distance into account when predicting the success rates, the prediction accuracy may be improved. We discuss this point later. In experiment 3, we used circular targets that appeared at a random position. The results were similar to those in experiment 1. The sigma can be accurately computed by the target size W, and the mean absolute error was 3.1%. In experiment 4, the effect of target distance was a bit clearly observed. The R squared values for regressing the sigma values dropped to 0.7, and the mean absolute error increased to 3.7%. This result also supports that taking the target distance into account is promising for improving the prediction accuracy. However, this assumption is rejected. We integrate the target distance and target size to regress the sigma. According to Beggs and colleagues, the square of A and square of sigma is linearly related. Therefore, we obtain the equation surrounded by the blue rectangle. But for the results of experiment 2, this model doesn't significantly improve the fitness according to AIC and BIC. Also, the prediction accuracy of success rates is limited. This conclusion is also true for experiment 4. Therefore, we found no clear benefit to integrating the target distance. We also analyzed touchpoint distributions and Fitzroy fitness. We found that the normality tests were not passed in some cases. For example, the red arrow annotates that the participants tap the target center less frequently than other positions. This violates the dual Gaussian distribution hypothesis. More repetitions are needed to measure the central tendency of tap point distributions. And in both 1D and 2D tasks, Fitzroy held very well with R-squared greater than 0.98. This shows that the both participant groups in day 1 and day 2 followed the instruction to balance the speed and accuracy. This is a summary of this study. Thank you for watching.